Okay, we are going to start looking at the lab from last week. I have here just some sample data, so I'm going to walk through how I'm going to calculate the analysis section. In the analysis section, we're going to calculate what is our theoretical temperature final, and then we're going to be able to compare that to, well, what was our actual final temperature from the lab, and be able to calculate a percent error based on those things. So you're going to use your equation heat lost equals heat gained, and you're going to solve for temperature final in both of those sets of equations. So negative ms delta T equals positive ms delta T, where this left side here would be like my hot water side, and the right side here would be my cold water side, since it's the one gaining heat. And then I'm going to solve for temperature final. If you look at my data here, the final temperature of my mixture for trial 1 was 20 degrees. So that's going to be what I'm kind of aiming for, but I'm going to see what my data tells me and see how close I really was. So the mass of my hot water and the mass of my cold water, I will have to calculate from my data up above. So I know that the mass of my cold water was 111.91. So of course you'll put in your numbers here. Specific heat of water is 4.18. Temperature final is what we're solving for, minus my temperature initial, which I'll have to grab from my data table. So my temperature initial on my cold water was 6 degrees. If I come over here to the hot water side, my mass of my hot water I calculated from my data to be 44.39. I'll use specific heat of water, 4.18. I'll take temperature final minus my initial temp of my water, which was 56.7, and I kind of ran out of room here, but I want to set those equal to each other. I'm going to have to do some math and distribute that through to end up solving for TF. On both sides, I'm going to have to combine like terms, and then I want a theoretical temperature to go here, right? Whatever I calculated from this math is going to go here in my data table. I'm not going to run all the math on it right now, but I think it comes out to be somewhere around, 20.4 degrees Celsius. Okay, so pretty close here. When I calculate the difference in this data table, all I'm going to do is subtract my two different final temperatures, and I'm going to make it an absolute value. So my difference might be 0.4 degrees. It's not going to be negative or anything like that. You're just going to have an absolute value result there as your answer. And then here, when I'm looking at percent error, I'm going to use the formula found right up here, and it says experimental value minus the actual value.
Hey, Mom. I want to be really quiet.
Okay, sorry, the experimental value will come from the experiment. So if I was going to calculate percent error, I would take 20 minus my theoretical, or the exact value, 20.4, and then I'll divide that whole answer by 20.4. That is as well an absolute value calculation. Percent error should not come out negative. I'll multiply that times 100. I'm not going to run the math on that either, but these percent errors theoretically should be pretty low. If you took measurements at the right time and in the right, in the right intervals, really making sure that you're being really exact with them, your percent error should be for sure under 5%. We're really hoping them to be under 1%. Okay, so that's how we calculate these three on this. You don't really need these three averages. I'm not sure why I put those on there. I would like an average of your percent error to be included in that. So once you get all three trials, your percent error is calculated, go ahead and include the average in that. So you'll do this MS delta T, this calculation, you'll do it 3 times, one for each trial, and solving for TF in each trial. Then you'll compare them to the final temperature values that you found in the lab. Okay, so that's the calculations for part 1. Let's go ahead and look down here at the second part of our lab one, which was we did the metal. In this scenario, we're going to set up the same equation negative ms delta T. That would be the metal side. And then the other side of my equation would be the water side, ms delta T. But in this instance, we are solving for what's the specific heat of this unknown metal. So we're looking for that guy. You know the mass of your washers, 40.89. You're going to solve for S. You know the temperature final for both, 14.3 minus 66 equals, now we're moving on to the water side. So the difference in my water is 40.2 would be the mass of my water. Specific heat of water did not change, so 4.18, and to do 14.3 minus 8.4 on my temperature side for water there. So I'll be able to solve the whole right side of the equation, and then I'll just move over things from the left to be able to solve for S. You'll do that twice. You don't need to report an average there, but you will need to do it one for each trial. Thinking about the rationales for specific heat of metals, we need to make sure that it's for sure lower than our specific heat of water, because we know metals conduct heat a lot better than water does. But realistically, I think that specific heat value should come out under 1. So if you're not seeing that, check your math and then see if I can help solve any of that. But that should be how we are able to run the calculations on both parts of our lab. So that should be ready to turn in. I won't see you guys tomorrow, but I will see you on Thursday. So this should hopefully be ready to be turned in on Thursday. If you have issues, you can see me on Wednesday. I know we don't have class on Wednesday, but we'll get it figured out. Okay, thanks.